for you guys, y'all had 2 weeks off this semester. So I think, you know, if you want to exchange the being off homework assignment, being off by the week and having that extra week off, I'm sure y'all will take that extra week. No? I was wondering. It's not too bad. All right, guys, ladies and gentlemen, if you would turn your books to chapter 8. Just skip a chapter. Ah, man. You know, I am going to skip some chapters later, um, but not these chapters because they're important. Like 8, 9, 10, 11. They're all important, you know. But let's work a problem. Let's find a good problem. See if we can find a good problem here. Let's see, chapter 827. Consider the duct system airflow, the average speed of the air in each. 8 by 10 ducts is 30 feet per second. That sounds like a good one. Let's do number 827. Do number 827. Let me see. Check something real quick. Man, I can't believe I didn't assign you guys that homework. All right, 827 is one of your homework problems. So it works out. All right. Anybody care to read? No. I figured since I was late, I'll read it. All right, number 827. Let's get it. Consider the duct system shown in the accompanying figure. Air flows through two 8-inch by 10-inch ducts that merge into a 18-inch by 14-inch duct. The average speed of the air in each of the 8 by 10 ducts is 30 feet per second. What is the volume flow rate of air in the 18 by 14 duct? Express the volume flow rate in feet cube per second, feet cube per minute, and then cubic meters per second. What is the average speed of the air in the 18 by 14 duct? All right, because I know you all remember how to do this problem. So I'm going to do my best of drawing the duct. You know, no worries about the jagged edges. It's okay. Ooh, they got really rough and rocky, but that's okay. And we got 30. Feet per second. All right, and then this is 18. It's different in the 5th edition. I'm reading from the 5th edition. Are you sure? This is the 5th edition that I'm reading from. So this is an 18-inch by 10-inch by 14-inch. All right. So those are our parameters. Right. I'm reading from the 5th edition. So these are our parameters. What do we need to do to solve this problem? What is the formula for volumetric flow rate. I think I called it V bar, when in actuality it should be V dot. That's how it will be termed in calculus. And maybe physics, can't remember. But V dot, what does V dot equal?
One sec.
Man, Lawson, you're the only one that took notes last week. Nobody knows what V dot equals. Well, what do we have, right? We have dimensions of this duct. They gave us an 8 by 10, two 8 by 10s, and then they gave us an 18 by 14. What can we solve from the 18 by 14? If you multiply 18 times 14, what do you get? Not numerically, but it would give you length times width of a square is the
250
area, right? But it's the area of a square. So they gave you the velocity
with
of the
area.
fluid. So how do you get the volumetric flow rate?
V1 A1 over A2.
V dot is equal to velocity times the area. There you go. Thanks, guys. All right, so we got V dot is equal to A. V dot is equal to the area times the velocity. Now, this is an interesting problem, right? Because you have flow coming in both sides of the duct. And the question is, what is the volume? What is the volumetric flow rate of air in this section? I'm gonna delete that. But what do we need to do to solve for the velocity, or solve for the volumetric flow rate in this area? So we can solve for volumetric flow rate in this area, right? And if the flow coming in this one and this one, it should basically be equal, right?
Yes.
Right. So then what do we do to do that?
Multiply.
Multiply the velocity times the area.
Yes, sir.
That's it.
And
So V, so I could just go 30 times 8 times 10 is equal to V2, that's the 2. Man, how do I make this? All right, there we go. So that's what we're doing. So if I were to come down here and I were to say V dot is equal to 30 and that's feet per second times 80 square inches divided by 144. I'm giving y'all this. That's a freebie. Square inches times 1 foot squared is equal to V2. And all of that's divided by A2, which is A2 is 18 times 14 was, what was that? You said it was 252? It's 18 times 4
Yes.
times 4. Thank you. So that's 252. Inches squared. And that's also over 144 inches squared times 1 foot squared. All right. So what is V2? You're not sure? You have a calculator, right? You have classmates. Nobody's helping. I guess it's like, man, we didn't do a, what do they call it? We didn't do a discussion starter. We just jumped right in it. Got to warm up, man. We didn't give us time to warm up. So you got 9.52. You don't know about that? All right. You got 16.7 cubic feet. All right. Everybody agree with that? Oh, that's funny, Lawson. You're funny. All right, that Mason got it. So everybody got 16.7. All right. So let me ask you this. What you did was solve for the volume going through one duct, but we got two though. So if you were to take away this one, right, exactly. So you got to double that. It's okay. It's okay. It happens. I've done it before. So now what do you get? All right. Now, something else to take into account. I know this is all scribble scrabble, but I hope you all wrote it down because I'm about to clear it. All right. Y'all are solving for Q, which is V dot, which is 33.4 cubic feet per second. Right? Which is fine. That's correct. But what we were solving for just then was V2. That's what we were solving for. So that should be somewhere along the lines of feet per second. So now that you know this, which is written horribly, but now that you know that it's 33.4 cubic feet per second, which is the volume that's flowing through the duct, what is the velocity? Nobody knows.
Divided by 118 times.
So what is V dot? How about that? Let's look at that. Start there. V dot is what? Not everybody else. It's velocity times the area. So V dot would be equal to V2 times A2, which is equal to V1 times A1, right? So seeing that we know V dot, then we just need to divide it by A2 to get V2. So what is V2? And remember, the area is in inches, so you got to convert it to feet. $16.7. 16.7 what? Is that right? Classmates aren't helping you now, Lawson. You're on your own, buddy. They're silent. They're mad at me because I was 15 minutes late. Well, not quite 15. You know, Cassandra P was gonna dip on me. Ah, so Chelsea has spoken or typed. So no, I mean yes, Chelsea, 16.7 feet cubic feet per second is V dot for one inlet of the duct. But what's the velocity? What's the velocity of what's V2? Small v. You tried. You did. You did. It's okay. All right. This is not working. Let's start over. I'm gonna have to draw my picture again. I know y'all loved it. All right. This is the duck. It looks like a pair of pants, right? Some spandex. That's what it looks like. I don't know what this little part right here is, but it's okay. We're gonna add it on. We're gonna make it work. Give it a little volume. That's what we're doing. Giving it a little volume. When I was in undergrad, I took an art appreciation class, and we learned that when you go from light to dark, it creates volume. It's called chiaroscuro for all of you art appreciation folk out there. But anyways, I just created a little bit of volume, right? All right, y'all, can y'all see the volume? Anywho, all right, back to the lecture at hand. From Snoop, back to the lecture at hand. We have the velocity flowing inside from each of these ducts, which is 8 by 10, right? 8 inches by 10 inches. Same here. 8 inches. I told you. Oh man. And then you just got some decor on the pants, right? This is that new school with arrows pointing up. But 8 inches by 10 inches. All right. Those are the dimensions. Those are the dimensions of each leg of those pair of pants. All right. And we got air flowing in these pants. What kind of pants y'all want? We're going to call them 7 pants. Not 7 jeans. They're going to be 7 pants. Because we ain't got no religion in our pants. So they ain't true religion. I know that wasn't funny, but it's okay. It's okay. In our 7 pants, the air is flowing in each leg at 30 feet per second. All right. I mean, that looks like a D. That's not a D, guys. That's a 0. Let me delete that. Let's see, y'all got to get this. I don't want y'all to be, I don't want y'all to be floored by the horribleness of the drawing. You know what I mean? I know that's what's confusing y'all. Y'all like, man, these pair of pants got air flowing through them at 30 feet per second. I don't know what to do. I get it. And then it's the same here. All right. It's the same down here. All right. I know y'all gonna give me a write up after the semester and be like, man, he wasn't that funny. His drawings were horrible. But I guess he's an okay teacher though. I know I'm silly. But anywho, so you got each leg, air flowing through each leg at 30 feet per second. And then you got air flowing through this section, right? At the 2 question mark, right? Oh man, you know that air feels nice, especially in Houston, because it's hot. Goodness, we need a little air. We need a little breeze flowing through there. All right, so for one leg, since A1 for each leg is the same, right? So we know A1 is 80 square inches, right? Well, let me do this. Let me do this. A1 is 80 square inches, okay? And B1 is 30 feet per second. All right, so we need to convert that to feet. All right, shoot. What's the answer? Anybody? 80 square inches converted to square feet. Go. What is the answer? What is the, yeah, what's, wow. 80 divided by 144. What's the answer? No. Done. Oh, man. So, do we need to do like breathing exercise? Do I need to have everybody come on and talk to me and then we just warm up our vocals? All right, cool, cool. Thanks, Lawson. Thank you. All right, 0.59 square feet. All right, that's a 9. That's a 9. I know y'all like, wait, what is that? What is that? It's a 9. Uh-oh, wait. Somebody got 0.56. Somebody got 0.55. Aim. Chelsea said aim. Oh, she meant same. All right. So we're gonna go with 0.56 then. Is that okay, Chelsea? I mean, I know you got the same as 0.55, but we're gonna just round it up. Right. I see Mason's loyal. She's loyal. She's a loyal friend. But everybody else like, Lawson, you on your own, bruh. But anywho, so we got 0.56. Hey, I'll take it. Because, just a few minutes ago, I didn't even hear the crickets. You know what I'm saying? The crickets were confused. They were like, hey, I don't know what you're doing, bruh. But now, people know what I'm doing. Okay, so that's a plus. That is a plus. So we got 0.56 feet squared for A1. We got 30 feet per second for A2. Now, what is V dot? Now, we've already solved this, right? So we don't even have to solve it again. So what is V dot? All you're going to do is do dos times V1 A1. Okay? And that equals what? We already know, right? We already know. I'm not going to make you tell me because we already know. It's 33.4 cubic feet. And I ran out of room. Oh, man. Whatever. That's horrible. Don't worry about it, guys. You're like, man, I can't follow that. Well, that's a F. That's a T. I know. I'm going to do better. I'm going to do better. It's like I can't like move it. You know what I mean? I'm gonna write it smaller. Try my best to anyway. See if I can do this smaller. I can do it. I think I can. Like the little engine that could. I almost got it. I almost have it, guys. Uh-oh. Get my T. Okay. This is taking a lot. This is like a lot of wrist control. Do you hear me? Per second. It is. Man, that took a lot out of my wrist. I feel like I got carpal tunnel now. It's like locking up on me. I'm just kidding. I shouldn't say that. I'm so silly. But anywho, so V dot is 33. All right, 33.4 cubic feet per second. All right. Now, what is A2? which is 18 inches times 14 inches. And that equals what? What is 18 times 14? I can do it in my head really quick. Let me see. That's 264 plus 18. All right, 252. Bam. I was almost there. Y'all give me about 2 more seconds. I would have done it in my head. So 252 square inches. Too slow. You're right. You're right. I can't beat the calculator, that's for sure. Unless it's zeros. Now, if it was some zeros in there, I could beat the calculator. But anywho, 252 square inches. All right, now we need to convert that to feet. So that is equal to, there we go. Thanks, Phyllis. Well ahead of the game there. 1.75 feet squared. Now you already know what to do next. V2 would then equal V dot over A2. And that is, go. No. Cricket, exactly. My gosh. Oh man, it's right there. 230, what was it? Whatever that was. The 33.4 about. There it is. There. Oh, thank you. Thank you. Whew, man. No, those units. Check your units. You got cubic feet per second. V dot is cubic feet per second. There you go. Whew, we there. Oh man. Now, when I grade y'all's homework, and if y'all don't have 827 correct, everybody's getting a 0 on their homework. I mean, all of you. I mean, every single, who all on here? Let me see. Everybody. Z's here, Javi's here, Sahil, Rick.
What if we already submitted
Mace.
it?
Well, you couldn't have because I haven't assigned it. So, right. You haven't gotten this assignment yet. But if y'all miss number 827, you're getting a 0 on this assignment. I'm so sorry. So,
No. I thought we were supposed to do it. My bad.
Well, like I said, you probably put something in it, but I assign this?
Yes, sir.
Oh, I thought I didn't. I thought somebody said I didn't. All right. Well, hey.
The homework and the journal has been assigned.
Okay, cool. Well, good. I'm ahead of the curve. Who said I was behind the 8 ball?
I mean, not during class, but we get the notification for this homework.
You didn't get a notification for this one?
Yeah, something in Blackboard say that we can do the homework.
Yeah, we got a notification.
Oh, okay.
Yeah, but not during class.
I have to check that. I know y'all just saying that because y'all don't want to get zeros on this homework assignment because y'all just got that problem wrong when y'all submitted it. But it's okay. It's okay. I'm gonna open it back up. Whatever happens. Y'all did it?
Yes, I'm checking my answer right now, and there's almost the same.
You got it right?
Yeah.
Yeah.
Oh, well, good. Oh, good. Well, why didn't y'all do the problem? Y'all had me doing the problem. Y'all didn't want to do the problem?
No.
I see. Okay. You know what? Class is dismissed. Y'all can figure out chapter 9 on your own. Do chapter 9. Y'all don't need me, right? Y'all can just do this on y'all. Yeah, I'm just wasting my time. You know what I'm saying? They gotta be like, Corey, why didn't you teach? I'm like, oh, they already knew. I got a smart class. I just assign them to work. They figure it out. Goodness. Man.
Hear your jokes.
Oh, that's what it is. Okay. Well, I'm gonna need more participation. Anywho, 19.08 or whatever y'all said. That is correct. 19.05, 19. It's the pressure. Okay. Well, there it is. Bam. Wham, bam. Thank you, ma'am. Now we can go on to chapter 9. We'll touch on a little bit of 9. We won't go over a lot because it's already 9 o'clock. I was 15 minutes late. Cassandra was going to bounce on me. My goodness. Just no love from you guys. For real. Right. It's just no love. Oh, okay. Some love. Make a little bit of love. Kind of love. Oh, so Mason, the presentation is on Thursday. I won't hold it against you, CP. You good. Yeah, so before I jump into 9, just to reiterate, the presentation will be Thursday. We're gonna start promptly at 8, not 8:05. I'm gonna start at 8. I know the class starts at 8:05, but I'm gonna give y'all a little extra time because I know y'all gonna go over your minutes. Y'all gonna get excited because y'all finally gonna be talking. Y'all normally don't. You gonna get excited. It's like, oh man, I'm talking. I can hear myself talk. Because I know y'all love to talk. I know y'all do. So y'all gonna get on there, y'all gonna get to talking, then we get to going and carrying on and on and on and on. And then it's gonna be 20 minutes before you know it. And I'm gonna be on there like, man, I wish I can get this during class. I'm not gonna say that. I'm not gonna say because we won't have time after that 20-minute presentation. So again, you got 15 minutes per group. I think I have 5 groups or 4. I can't remember. Is it 4? I don't remember. Y'all better remind me. I think it's 4. I'm gonna go with 4. I only have 17 people in the class. Yeah. Gotta be 4 because 2 people dropped, so they didn't like me. So they dropped me. Go figure. But so we got 4 groups. So if we go 15 minutes per group, that puts us right at an hour. And then when you factor in Q&A and changeover, you might want to add another 5 minutes per group. So we'll probably get out, if everything goes promptly, around 9:30. 9:30 at the latest. 9 at the earliest. All right. And let me see. If I got 17 people in the class, 2 people aren't here. So just tell your partners, whoever isn't here, just let them know. Got 4 groups, 15 minutes, 5 minutes, QA, another 3 or so minutes for you guys to get ready. So let them know. And if they can't be here, let them know that they're getting a 0. All right. I'm just kidding. They're not going to get a 0. They'll get a 50 because they didn't show. I'm just playing. They're not going to get a 50. Y'all let me know what y'all want me to give them because it's going to be a participatory thing. So I'm just playing. I'm just kidding. I'm not giving nobody a 0. 100 for everyone. Absolutely. So I love it. Everybody's getting 100. So y'all don't even have to present. I'm just kidding again. I'm just kidding.
Hey, everybody heard that. We're all getting 100.
Yeah, y'all are. Y'all gonna get 100%.
Yes.
For your attendance. So that's what you're gonna get 100 on. 100% on the attendance. That is true. It is recorded. Oh man, I'm gonna edit it though. I'm gonna edit that. That's gonna be the first one gonna get deleted. Ricky said we get the day off. Oh man, no, not quite. Y'all just come on and just present, and because so I can hear everyone. I don't really know what you guys sound like. Anybody could be like, coming in and taking notes for you guys. So I'm pretty sure y'all don't want somebody to present for you. Right. I'm gonna keep that get a 0 part for this homework. You absolutely right, Phyllis. All y'all getting a 0. No, I'm just playing. No, I'm just playing. Y'all better get number 27 correct though, because we spent an hour on that thing. Well, probably not an hour, because I know CP over there, like, well, you were 15 minutes late, so it was like more like 30 minutes. So I already know. I get it. All right, let me go. Let me pull up chapter 9 so you guys can get up out of here. Yes, I'm feeling some type of way. You know, I feel like, people should wait on me, because I'm such a nice person. So y'all should wait on me if I'm, 15 minutes late. You know, I feel like you should wait. But no, let me stop playing. Let me, because chapter 9 is probably, 9 and I think 10 are probably the toughest. No, 9 is not that bad. All right, I'm gonna stop. I'm gonna stop throwing shade. I'm gonna stop throwing shade. I appreciate it, Felicity. You not noticing me being, late. So you gonna get extra credit. No, and I'm just playing. Everybody's gonna get extra credit. Because I don't want to. I don't show favoritism. Maybe a little bit, you know. Well, maybe I don't. I don't know. I have to think about that. What happened to my download? There it is. Or do I have it up already? I already have it up. All right. Mass and mass related variables in engineering. There's a lot of important things that I want to discuss here, but for the sake of time, we're going to pick it back up. Things we want to go over: mass as a fundamental dimension, density, specific weight, specific gravity, and specific volume. All right. What is mass? There's the definition. But when you think about mass, right, you think about, well, you probably don't think about mass very much, because in our world, in our society, we always think about weight, right? We don't think about what makes up our body, because we just look at weight. It's like, how much do I weigh? How much does, well, maybe not. Maybe we don't think about weight as far as how much we weigh, but we think about in terms of an object, you think about weight. You don't think about mass. But then in SI, when you think about the SI units, they measure everything in mass, because it's, well, not everything, but mostly. Because like my pet, our dog, our little JoJo, out his food, it's in mass. He gets 30 grams in the morning for breakfast, and then we don't feed him again until the evening. I feel like that's cruel, but that's what the bag says. Twice a day, feed him. But anywho, then we'll weigh it out again in mass, right? He'll get another 30 grams or 25 grams later in the day. But it's basically like what makes up the object, the everything. When you're looking at the matter, the molecules, the atoms, when you think about everything collectively that makes you, that holds a mass, right? Now, when you place it on Earth or on the moon or wherever where there is gravity or a gravitational pull, then the object gains a weight, right? Because of the force that's pulling it to the surface of wherever you are, right? And obviously that's going to vary, right? Because the gravitational pull differs based on where you are. Even in the Earth, the gravitational pull differs. So like when you're up in space, obviously you're lighter, right? But your mass is the same. Or when you get closer to the atmosphere, not the atmosphere, the Earth's orbit. When you get closer to Earth's orbit, your weight changes. So when you're up 30,000 feet up in the sky, obviously your weight changes, right? But your mass is the same. A lot of that's reading. I'm not gonna read a lot into that. And like we was talking about units. So for SI units, gram, kilogram, milligram, things such as that. All right. Then you have pound mass when it comes to the English or the US customary units or British units, slug. They also use pound mass. Just for a few things, I think we've gone over this before when it comes to dimensions. We haven't gone over specific gravity. We're not going to go over that right now. Then we go, really what I want to get at is mass flow rate. And then, let's see. We're not going to go over momentum either. But mass flow rate is basically the mass of the object, the movement of a mass over time, the amount of mass that flows through something per unit time. And somebody pinged me. Is there a question? Oh, you can't see it? Hold on, let me go back. Can you see it now, Cassandra? Okay. Okay. Well, yeah, I know, right? Well, okay, no worries. I'm gonna stop right there. All right, I'm gonna stop right there. Because I want to I want to work an example. I want to work a different problem when it comes to mass flow rate and volumetric flow rate. More or less, I want to do a conversion problem. So I'm gonna go back to that same problem. Well, no, it wasn't just you. It was other people. They couldn't see it. So it wasn't just you. So, well, don't exit because I want to see if you can see my whiteboard. Because all I'm going to do, I'm just going to do one problem. We'll do more problems next week. But I just want to jump start your brain on mass flow rate. Can you see my whiteboard, Cassandra? Cassandra P. All right, cool. Now, just a few minutes ago, we solved for V dot. All right. And I know you guys, well, let me see. What was V dot? Let's see if I can get some participation. What was V dot? Ooh, crickets. There it is. Thank you, Cassandra DeLeon. And that was cubic feet per second. All right. If that was the volumetric flow rate, and this is of air, right? Air. What is M dot? What is M dot? So let's look at a couple things. Density is what? Rho. What are the units for rho? What are the units for rho? Mass over volume? Is that it? All right, then. So what's rho air? What's the density of air? And we're going to assume atmospheric temperature. The density of air. I know. Silence again. I'm just going to wait. Sooner y'all find out, sooner we'll be done with the problem. Should I play some elevator music? I'm just kidding. All right, that's good. That's perfect. But guess what? Our volume, our V dot is in feet. So what's the density of air in US customary units? I know you're like, man, now you're asking for too much. I know, man, I know. I'm sorry. I'm so sorry. I'm gonna do better. I'll be more specific next time. All right, so Lawson got 0.823. What are the units, Lawson? Pound mass per cubic feet. Is that what everybody got? So we're gonna go.
I forgot the 3.
No, it's okay. 0.82. $9.8 pounds per square inch. Okay, Cassandra got 0.0765. All right, now we have a dilemma. Lawson, you got 0.8. Cassandra has 0.07. Now I'm going to need somebody to break the tie. That's funny. Oh, now Cassandra S has 0.95. All right, so we just going to take an average. No, I'm not. I'm not picking anybody. It's not. It should be in your book. Yes, imperial units are the same. So, Cassandra, what were your units? Cassandra S. Ah, well, that's why. So, 0.075 will be 0.0765 is it then? Because we need it in US customary unit. And then it's meters squared, and then it should be it should be pound mass. All right, cool. So we're going to delete this And there it is. So 3 people got it. All right. So it is 0.077595 da 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 da. So we basically go 0.076. 0.076, and that's pound mass per cubic foot. All right, now by looking at this, what are the units for m dot? What do you think it would be? The flow rate, the mass flow rate. What would the units be? No worries, I'll tell you. Pound mass per second. All right, that's what m dot, those are the units. With that being said, what do we need to do to get those units from this guy and this guy, or this gal and this gal, this guy and this girl? I don't know. I don't want to be, sexist. I'm just, everybody is welcome. So, what are we going to get from them? What do we need to do to manipulate it? No. Multiply them. So if I multiplied lbm feet cubed times feet cubed per second, that cancels, then I got lbm second. Bam. Sounds good to me. Everybody agree? So when you multiply that, Felicity, what do you get? M dot is equal to 1.45. Et voila. And that is a wrap. So next class, we'll do the actual homework problem, and we'll go over momentum and probably go over some other stuff too. All right. And we'll probably work another problem so that you can see this work fully, how we're solving for volume. And if we don't know the density, we'll solve for volume. And then we'll solve for m dot using volume and volumetric flow rate and something else. We'll figure it out. We may know the mass of the object. So, all right. Did I confuse you all enough? Yes? Okay. Sorry. All right. Good deal. Well, that's all I have, guys. Cool. On all counts, I'm happy that I confused you. I'm happy that I didn't. And I'm happy that I never do. All right. You guys have a great night, and we will listen to you on Thursday. I'm looking forward to it. I'm excited to see what you guys talk about. This is like my best class, like the presentation I get to hear from you guys. I love it. Extra credit. You might get credit, but I don't know about the extra. There will be credit for you attending and presenting. Extra, I don't know. There will be a bonus on the test, though. There will be a bonus problem. I can't remember what I said I was going to make the bonus, though. I'll figure it out. I'm going to make sure it's extra crispy. Extra crispy. That means extra hard. I'm just kidding. It won't be hard at all. It'll be easy. Well, you all have a great night. Adios.